people can actually review the lecture. Okay, so agenda for today's lecture will be discuss what design patterns are, kind of an overview, why do we need them, not so much who invented them, because I think that's more historical information, but more about why they were invented, or I should say written down. We'll discuss different types of patterns because people who usually talk about design patterns, they kind of separate them into several distinct groups in terms of their responsibility. And the general idea or general sense that a developer can have about design patterns includes understanding what are those kind of types of patterns and groups of patterns that immensely help kind of like structure the whole thing that design patterns talk about. So we'll discuss what are the creational patterns, why they're called creational, then structural, the same thing, and behavioral patterns. So 3 groups of patterns. They were originally designed in this way, kind of. That's what they call design patterns. So they solve creational problems, structural or structurizational programs, and behavior-driven problems. And now, what are the design patterns in general? So if we kind of spend enough time in the industry, in the IT industry, we kind of end up at the point that some of the solutions that we write daily could be kind of saved and reused all over the place. But the thing is, those solutions that people write, they tend to write it separately from each other. So unless you do some kind of pair programming, you kind of biased in your solution. But the problems themselves, they tend to be the same across the whole IT industry. So at some point, people thought that it would be nice to have like kind of a single source of truth, kind of gather all the problems that people usually encounter, divide them, separate them into several groups, and then discuss and compare their solutions that people typically have for these problems. And that's how the design patterns were born, as a way to kind of categorize the solutions, give kind of an middle ground solution for a typical problem, so that people can either use them directly, use as an inspiration, or just directly copy pasting them into their code, or use design patterns and the problems and like the whole name domain as a way to communicate with each other, so that when I say, hey, let's use a creational pattern here, developers who are aware of the design patterns kind of understand immediately what I mean and what are the choices on the design patterns. If I name a specific pattern, for example, a factory, you immediately have an idea of what I'm talking about, either from the meaningful way, like the purpose that I'm trying to convey, and from the code perspective as well. And design patterns are not specific to any kind of language or framework. They're interchangeable. It's a very unique thing in terms of IT. It's like saying that, hey, I write code, and you kind of immediately get the idea of what you're doing, but not necessarily what language or framework or I don't know, technology you're using. Same with the design patterns. I'm using a factory pattern means that, yeah, I'm doing the creational of some kind of entities and objects, but I'm not necessarily conveying the language or framework meaning. So think of them as a general computer science knowledge. So since I mentioned some of the patterns already, and I started with creational, let's talk about creational patterns more deeply. So as you can see, a simple definition on the screen denotes that it's all about creation of something. And usually if we talk about classic languages like C, C++, then, and maybe some of the languages that use them on backend, like Java, C#, etc., they tend to operate at the object level. And we know, for example, JavaScript is also a object-based language. So that would be cool if we had some ways to kind of do the creation of those objects in a understandable and categorized and well known way. So that's where the creational patterns were born. So it's all about creating something. So in a JavaScript world, it would be objects. So what are the patterns that we have here? I'm sure that you kind of encountered them already. And they all talk, again, about creation of some kind of objects. So prototype or class pattern, it's all about kind of objects that are instances of something or kind of connected to some higher level object or class, parent, name it yourself. Constructor pattern, it's all about the process of constructing that object. So the focus is not about the connections that an instance has to a creation class, but on the construction process. I don't care what the inheritance and what the instantiation process is. I just care what would be the insights of the object that I create. So I'm constructing or building this object. Then singleton pattern is all about saying that, hey, I want just one instance of that object. I don't care about the insights. I don't care, again, about the inheritance. I just care that the object that anyone in the system ends up having is the same kind of object, even if they don't know about that. So kind of like a single source of truth. Again, if I have a big system that has lots of different places where objects can be created and lots of different ways that those objects could be created, it's a good thing to have a factory for their objects. Because when I need some groceries or maybe shoes, I just make an inquiry for the factory, hey, make me some shoes. For example, Nike shoes. And the factory just spits out Nike shoes. If I ask some Puma shoes, I don't know, sneakers, or maybe some other type of shoes, the factory still spits out the actual shoe pair with the properties that I asked. I don't really care about how it's implemented. I just say what I want to have. So factory, it's a pattern in of itself, kind of self-explanatory. And the abstract factory, you can guess that it's something like higher level than just a simple factory. It could be a whole industry. For example, I use this abstract factory and say, hey, I want shoes, and I want some suit, and I want some, I don't know, boat, for example. And the abstract factory gives me those things, and I don't really know if there is a single entity creating these things, or in fact, there are multiple of them, and that's all the pattern is about. So abstract factory just abstracts away the number of factories underneath that receive the message that I give to the abstract factory. So each factory will receive, okay, shoes, then boat, and then shoe, the suit. There'll be 3 different factories. They will, again, abstract away how they create those objects. But anyway, they give them back. So you, again, have an ability to create new objects. So as you can see, the whole thing, the whole set of patterns, it's all about creating and solving a particular problem. And the way you think about patterns is not by memorizing all of them or trying to kind of apply a specific pattern to all the problems and see where it fits. It's all about understanding the problem domain, then choosing either the creational pattern, structural, behavioral pattern, then narrowing down and choosing the actual pattern and implementing that. So going further into our lecture, we have structural patterns. We already created a number of objects. So like on the picture, we already have some people objects, for example, but we now want to kind of organize them in a specific structure. So kind of assemble them into a meaningful form, because in life we have different kinds of objects like bricks, wood planks, etc., etc. But to actually benefit from those objects, we need to organize them into kind of a meaningful thing called a home, for example, or a house. Or like in the pictures example, an organization that works and delivers some products or services. So structural patterns are all about those organizational things. Again, as the name says, it is solely focused on structure between the objects and the object represent, but never about their internals or the way they created. So structural patterns work with objects as is. And what do we have inside our structural patterns list? Several patterns. Some of them may be, again, known to you already. For example, module pattern is all about having a small piece of code that is kind of isolated from other pieces of code in your project and not polluting any things. Or maybe, and that module will contain all the objects that we want to be there. And that's how we convey the meaning that these objects are kind of doing the same thing in our own kind of organization. So module pattern, again, you might be familiar with it. We have ES6 modules. We have common JS modules. We have different kinds of module system that I talked you through already in the previous lectures. But at some point in history, we didn't have any way to organize modules in JavaScript. Moreover, we didn't even know about this approach until some people sat down and kind of thought about the whole isolation, separation of concerns, and kind of organizational, structural approach to the software development, and they end up creating this module pattern. So module pattern is all about isolation of your code, objects, etc., in some kind of sealed unit. It has some input API, it has some output API. They're declared. You can use it as is. Within mixing pattern, you have an ability to kind of adjust the behavior of some kind of other objects or assemble them in a way that they are freely accepting new objects inside the structure to deliver their solution. Think of it as, again, as a department in some organization. They have a number of people inside. They all do work, so department delivers some products, but you never know about the people, about the objects inside of those, of the department. For example, you can add a new person. you kind of think of it as adding a new object in that in your structure of your code, and having that object deliver some functionality. So mixing pattern is all about kind of increasing a number of functionality or features that some piece of code has by adding an object and adding a feature. It kind of contrasts with the OOP versus functional programming, or OOP versus composition, that sort of thing. So mixing pattern tells you only about the adjustments or improvements into some system by adding new or removing old stuff. Facade pattern, again, it's like a building facade. You have a beautiful front side of the building and awful yard, for example, as some cities have, or maybe vice versa. You have a similar looking buildings on the front side, but the people living inside decide that they want to have a unique garden behind. So either way, you have a way to separate the internals from the external, so what you are from what you show to the world. Facade pattern is all about that. Flyweight, again, kind of misleading name, but flyweight pattern is all about weighing so little that you kind of fly. And all I mean by that is that some systems, doing their work, they create lots of variables, lots of objects, kind of not really caring about memory, about performance and all of that. And flyweight pattern as a way to organize that creation process, maybe, or organize the relationship between the object created, is all about reducing the number of objects, or increasing performance, or reusing memory in a very nice and smart way, so that instead of creating 1,000 objects with 200 objects being exactly the same, you kind of create only 800 objects, or 801, and that one object represents all the 200 same objects. So it's kind of like a way of reducing, again, the weight of your system. And decorator pattern, again, if you have you might have known this already, but the decorators, they will be at some point a part of the JavaScript language itself. But at this point, we have decorators as just a way to extend some functionality, almost like the mixing pattern does. But mixing pattern introduces some objects into system or functions into system, and decorator kind of wraps the system around, and you then use this wrapped object instead of the original one. And by wrapping around the object, you kind of get new way that the system behaves, or number of objects. So as you can see, it's all about moving around objects, maybe kind of organizing them, or concerning the relationship of objects. And that leads us to behavior. So the behavioral patterns, as well as the other two that we already discussed, they too focus on the insides only, not caring much about how the outside of those objects work, how they organize, how they created. They kind of focus only on the stuff that is inside of each and every object or system or functionality or class, anything concerning the actual implementation of an algorithm, or maybe implementation of a state inside the component, or anything like that. This is all about the behavior. Again, so going back to the example, you can think of that organization. They hire new people, so kind of create new objects inside an organization. Then they organize people there, kind of creating a structure. And then those people, they have their own way of doing things, way of working, kind of way, mood, skills, etc., etc. So behavior pattern kind of zoom in and talk about the behavior of each and every object. So in the behavioral pattern list, we have a number of patterns. Some of them, again, you might already seen or heard. For example, the second one, the state pattern, is really popular one, and most of the React or Vue or Angular developers not really aware that they're already using that. They just use the word state and kind of as is, without concerning themselves that at some point in time, back in the days, we didn't even think about having kind of a class or having a function saving some kind of internal state of itself every time it ran for later use. So state pattern introduced this saving mechanism, kind of treating each object as not just a thing as is, but as like having a lifespan of some sorts. And the state pattern is all about kind of like keeping in touch with the actual state of things inside your system, inside this object, inside of the function, with JavaScript closures, for example. It's all about this thing. Observer pattern, also very well known, all about notifying a set of people or set of objects, I should say, inside your code system that are interested in your changes. So it's like observer pattern might be a manager of some set of the people inside the company that notifies them about the learning opportunity if kind of something arises. So this observer is the manager, and that manager has a list of people that they care about, and then at some point they notify it. If they don't notify other people that they don't kind of care about in terms of the managerial structure, people can't just approach them and say, hey, if something happens, notify me. It's not about this pattern, it's some other pattern, but the observer pattern is all about one object notifying a set of known objects about some changes. Same kind of with chain of responsibility pattern. It's you can think of it as an escalation example in a company. If your team lead kind of has difficulty solving your problem, you go to project manager. If the project manager can't solve your problem, you go higher to delivery manager, and then finally you receive some answer whether the problem is solved or maybe not. So chain of responsibility is a way of organizing the methods and things, the actions that happen in your system in a predictable way, declarative way, so that the outside world doesn't really know about this whole responsibility or chain, sort of, so to say. So your problem doesn't really care how you solve it, with the help of which person, but you do, and you say that, hey, first of all, I will go to my team leader instead of going directly to your delivery manager, because they kind of have a different set of costs, I should say, cost of asking, time, sensible costs to ask help of a delivery manager compared to a team leader. So, and you kind of structure your code in a way that you have responsibility chain. Iterator pattern, again, at some point in time in like IT history, we didn't know that having a list of something and going one by one through the list is a well-known and well-used way, and everybody just kind of wrote their own iteration process or going through kind of process. So people just thought, okay, let's move it to make it official. Let's call it an iterator pattern. An iterator pattern is all about having a list of something and going through that list. So kind of how you go through that list. Is it one by one? Is it a random iteration? Is it every two? So that's that kind of thing. And then doing something every time you iterate. So we used to not have that lined up with everybody else. Strategy pattern, again, a more high-level pattern. It is all about abstracting away the algorithm that is used in your system. It's all about the chain of algorithms, because chain of algorithms usually means that we kind of set up a fallback solution or different kinds of things that could solve your problem. Strategy pattern is all about choosing what to use to solve a problem. A typical implementation, or not the implementation, but application of a strategy pattern would be authorization system or authentication system in a website. So whenever you press login, the website could show you different ways that you can log in using Facebook, Google account, or maybe GitHub account, or their personal email and password system. So that's where the strategy patterns is the most well-known. Memento pattern, again, kind of almost the same as like state pattern, also about memorizing the way, but it's all about not the lifespan of some kind of component or object or class, etc., etc. It's all about external storage of some info. And people thought that that could be a really cool solution. Instead of bloating out state pattern, let's create a new one and call it Memento. So Memento is a external to your class or object or system storage of some kind of state, we can say. Mediator pattern. Mediator is something that stands between two objects or two systems or any two things, kind of hiding away those things from each other. So these two classes, two objects or two things, they know about mediator, but they're not aware about anything else. So it could be two things, there could be a number of things that all use a common mediator thing, mediator object or class. To solve their problem, they just submit the request to the mediator. Mediator kind of knows who can solve that request, and it just kind of delivers the request to through the system to the necessary object, necessary solution. So combine the mediator with observer, and you get the famous PAP-SAP system. But that's kind of out of scope of classical patterns. And we have a common pattern. Might sound a bit similar to strategy pattern. It's also a pattern to kind of call different algorithms to solve your problem or to deliver something. But the main difference is that the methods that you choose, the algorithm that you choose, might not do the same thing. So instead of kind of having an object with a list of methods, like get, post, put, delete, for example, you have an object with a single method do, and then you pass do what, kind of this string, so do, put, do, post, do, etc. So common pattern, some systems are using this common pattern that's kind of beneficial to them. In the past, we had something called, not in the past necessarily, but that's not just a well-known thing. We had remote procedure calls, and they kind of looked like common pattern where you had procedure call, meaning that you call a specific function and you pass a name of the procedural function that should be called on the backend, for example. So common pattern, switch between different methods that might do different things compared to strategy pattern. And that's all. Actually, that's all of the patterns that I wanted to mention in this kind of lecture. I have a number of links will be available to you in the presentation that you can further kind of read through them. One of the links leads to my own kind of opinion on the design patterns, implementation of each of the patterns that I mentioned today, and a bit more than that. So at this point, we're at the end of the lecture. So if you have any other questions, please ask. Otherwise, I'll be showing you some code, several examples of patterns that we talked about. So if you have any questions? Okay, no questions so far. That means I'm doing a good job. Okay, cool. Let's look at the creational patterns first. So the most well-known may be singleton pattern. This is a rough implementation of the singleton pattern, for example. So as we mentioned already, singleton pattern is all about avoid creating an instance of some sort or object of some sort if it's already been created in the system. So we can have a class singleton car, and we try to use this singleton car to create an instance of a car. We pass maybe a number of engines or type of engine or number of doors, engine, and the color, and then we have this singleton of a car. Then we do the same with a new car, and we end up creating actually the same one. So the way we do that, for example, because we kind of want to reuse stuff, it's a silly example, but still it delivers an option. We want to create a new object, but we end up creating the same one, or actually not creating, but directly using the same one by reference. So that'll be the same object. And the way we do that in the constructor, at the point of creating a new instance of an object, we first check if the instance has been created already. If so, return that instance. If not, create the instance and save it somewhere outside of the class or the factory, the singleton. So that's what it is. So we have an outside way to save it, save some instance, storage or something, and then the singleton would actually check that storage in case there is an object or not. That's a singleton pattern, or a factory pattern, kind of also a well-known pattern, so I decided to show you that as well. So we have a cool car class and a car factory, and that's how we use it. We create an instance of a factory, then we use that instance of a factory and call the method inside the factory saying that, hey, I want to create a car named Mazda. And then at some point you call the same factory and say, hey, I want to create a car named BMW. And they are completely different entities compared to singleton. So inside the factory, we have this method create car. And yeah, as you can see, I just used this new car without a constructor, but you can actually specify some useful things inside. So we have a method of create car, it receives the type, and then using a simple switch case, we use the actual class that creates a car, but we specify some values there, pre-made, kind of like. It's mostly about how the actual car factories work in real life. They don't receive orders and ask people to specify exactly what should be inside of the car. They just have some models that they produce over and over again. That's why it's called factory. And the actual car class would be the same as the usual. So it has some constructor and a drive method that should be available to all of the instances. So yeah, that's it. That's a car factory. Then we go to the structural pattern. So module pattern is the one that might be used, you might have seen using in the old days in the way of having this immediately invoked functional expressions. So without getting into the details of that module, we have this ETH module object. We call the methods inside of that object. We do stuff, but the way that we create that object, for example, imagine we have we program in the JavaScript outside of any module system. That means that everything that we do in each and every file that we kind of where's that that we append as a script tag would be in the same scope. That means you have to be cautious about the names of the variable. You don't want that, so you use the module pattern. And that's what people used to organize module patterns in the past, ETHs. So, and then you have inside of the ETH, it's a new functional scope. You have all the methods that you want to have, and then you return from that from the ETH something that would be called an API of your module. So, application programming interface, and this is how you use it. Same with the actual objects. But for the actual objects, you don't organize them into APIs. So you don't have a direct control over what will be available and what not. You do have getters and setters, but for the method, that'll be kind of tricky. But same thing applies. Everything inside the object would be not available outside of the object, and that's the whole premise of the module pattern. Facade, or maybe actually decorator would be a good example. Let me see. Yeah, let's go with the decorator because you might be familiar with that as well. So for the decorator, the main thing would be, let me just take a look. What would be, yeah, this example would be perfect for our lecture. So imagine I have a function or function constructor, I should say, that has the number of properties. They do some kind of thing, and just by directly using it, I do have some kind of functionality. I do have access to costs, to the screen size. So kind of I create my MacBook, but I want to customize it so that people who buy my MacBook would receive some kind of personalization to their thing. And by doing the personalization, I apply some costs. But I don't have kind of like a method inside my MacBook that says increase costs in case customization. That would be kind of silly thing to program. Instead, I have this method available outside of my MacBook itself, because some people would just go with a simple MacBook without any of the customization, and it will be fine. So I don't want to waste memory inside of the MacBook. That's why I create a separate function that, as you can see, uses some kind of wrapping around. So wrapping around happens at the level of one function storing in closure the actual object or function, and then doing some additional stuff. So, and that's how I use it. When you see a function call and following another function call like without return statement that usually is a decoration. So the main thing, I separate the change from my object, and also I separate what change would be applied to the actual object. So that's kind of a way to customize your code using the decorator pattern. And finally, I think we'll look at the behavior pattern. And for example, let's look at the strategy that I think that would be the most useful. So let's look at the high-level picture of our code first to understand what we're trying to do. Yeah, so imagine I have some goods that should be delivered from one place to another place, and the weight is this. And that's actual, maybe some kind of Amazon product that you bought. And then you want to kind of create a shipping of that object that you just bought. And then the shipping process is started, and the system asks you, hey, what shipping would you like to have? And this is how it's internally organized. So if we use the shipping with UPS, we'll get one price of the shipping itself. If we use DHL, we get another, and FedEx would give us another. So we kind of have an object shipping that we just created for this specific goods. The shipping and goods are separate things. So shipping does not care how many goods you buy, or in terms of like, they don't really decide that, and they have no control of that. You just at some point provide the goods to them, and they're responsible of counting number of monies that you owe to them. But what they care about is the actual way of shipping different kinds of things. And that's what we're trying to be here. So the shipping process in Amazon is kind of a method of calculating using what strategy, how much money would be spent when we deliver some actual goods. And that's how it's organized. So we have a shipping that will have a method to set the strategy. It will be saved inside of the object itself. So a company that's doing the shipping, and then a method calculate that would use the company method and call its internal calculate method. Because again, when you do the shipping, Amazon is only creating the shipping process, but the actual shipping would be done by the company itself, so that the company itself is charging you, not the Amazon. Amazon just has some VAT applied to the shipping. And then the actual objects would definitely have their ways to calculating your price of the shipping. So to summarize, strategy pattern is all about having different algorithms of doing something, in our case, calculating price, and then switching that strategy, switching the algorithm using a separate method. So that's how we hide the implementation detail, the implementation kind of overhead from the usage of our code. So instead of calling the calculate DHL, DHL or calculate, and then writing the same kind of code inside of the shipping itself and calling it FedEx, and kind of bloating out our shipping, we abstract away the actual company, and this is how we organize the behavior of our code. And that's roughly what I wanted to show you today. For the rest of the patterns, you can go check out my GitHub account with a repo called JavaScript Design Patterns if you're interested in. And At this point, I conclude the lecture. If you have any questions, please let me know while I'm still there. If not, we'll be saying goodbye. Okay, cool. What's the most common pattern to use? Again, it's not about choosing the most common pattern and then applying that pattern to your problem. It's the other way around. You understand the problem, then you choose what the type of the pattern that problem kind of falls into, the behavior or structural or creational problem, and then choosing the pattern that solves your problem. So my advice would be going from the problem domain to the pattern instead of kind of trying to learn the pattern and then try applying the pattern to your problem. The ones that I mentioned in the lecture the most, kind of like the ones that I showed you in the code, are the ones that I think are the most well-known and well-used, but a good software engineer knows a bit of everything. So it's a good understanding, it's a good practice or exercise to kind of go and write some code for all the patterns that you want to know, so that whenever the opportunity comes, you just show how smart you are and use that pattern. Okay, cool. If you don't have any questions, I say that we conclude this lecture and see you again next time. Bye.